Alright, I'm going to do this for the whole class. That way you can go through your feedback loops and self-assess, make sure you have all the necessary components, and then after you do your final submission, I'll go back through and make any additional comments or suggest some final changes on the feedback loops. From what I've seen, everyone was off to a pretty good start, and some people were even, right on it with the necessary elements of the feedback loops. So I'm just going to go through these things kind of like I did in my other video and show you the necessary elements for each feedback loop. So for ADH and water volume, ADH is antidiuretic hormone, and it regulates water volume. So the first thing you have to understand before you could really begin the feedback loop is, how does ADH regulate water volume? Does it increase water volume or decrease water volume? And so if you didn't know the answer, or don't know the answer to that question, then you won't really be able to create a successful feedback loop. You first have to understand the action of your hormone. So each feedback loop, first of all, is in a loop. I did have a couple submissions where it was like a line of boxes, or it wasn't, a closed loop. But the thing about a feedback loop is it's continuous. These feedback mechanisms happen continually. So your diagram does need to be in some sort of loop formation. So with ADH, and really with any feedback loop, you can begin with a homeostasis box. So this would be water volume within normal range. So for this feedback loop and the other as well, it begins with a stimulus. So something occurs that's going to create a change. There are several possibilities for stimuli. There's not just one stimuli that can occur. But in this feedback loop, I wouldn't use a stimulus that wouldn't change the water volume. So, for example, if I said, got a fever, well, that's not, that's a stimulus for some things, but that's not really a stimulus that's going to kind of jumpstart this feedback loop. So it needs to be a stimulus that affects water volume. So after the stimulus occurs, you need to indicate, how does water volume change? Does it go up or does it go down? Does it increase or decrease? Now, ADH, this matters. There is like a correct change that goes here, because ADH regulates water volume in a specific way. So like I said in the beginning, you have to first know, what is the action of ADH? Does it typically increase water volume or decrease water volume? If you don't know the answer to that question, that's where you need to start. From here, you have to consider, what's the sensor gland? What gland is going to detect the change in water volume? Now, I will tell you, the special component of this gland are called osmoreceptors. Now, the first gland, and here's another hint to help you, the first gland does not secrete a hormone. It signals the second gland. So the first gland is the sensor gland. It has osmoreceptors that detect the change in water volume. Then this gland activates the second gland. The second gland will then secrete the hormone, which I'll go ahead and tell you, and this isn't a secret, it's antidiuretic hormone. or ADH. So really that's what needs to go in this box. So the blank which is the gland, secretes antidiuretic hormone, or ADH. So from here, what is the target of ADH? Where is ADH going? What's the target? It's an organ. So what's ADH target organ? This is on your hormone axes, if you need to take a look at that. When it gets to that organ, what does it do? How does it interact with part of that organ or the cells within that organ? And then what's the result? So the result, and I'll go ahead and put this in here too, should be the opposite of the change. Because the whole point of negative feedback is that the result counteracts the change. The final output counteracts that initial change that took our body away from homeostasis. So for your ADH water volume loop, these are the components you should have. Homeostasis, that should be your start and end. A stimulus. Again, there's many possible stimuli you could choose from, but the stimuli need to actually apply to the scenario. Change in water volume, but you need to know, does it go up or does it go down in order to stimulate the secretion of ADH. Then the sensor gland. So what gland, osmoreceptors on what gland will detect the change in water volume? This gland will signal a second gland. The second gland secretes antidiuretic hormone. That's our hormone in this feedback loop. Antidiuretic hormone will target what organ? Again, that's right there in your hormone axis, or axes. When ADH gets to that organ, how does it interact? What does it actually do within that organ? What's the result? So at this point, does the water volume go up or down? And again, it should be the opposite of this box, because we're balancing out the scale, bringing us back to homeostasis. So if you notice in your feedback loop that you only have one gland, or you don't, like you say, okay, the gland secretes ADH and that's where it ends, then you do not have all of the necessary components. Okay, so you need at least this many parts to your feedback loop. Now, for calcitonin and blood calcium, calcitonin is different from parathyroid hormone. Calcitonin does the opposite of parathyroid hormone. So if you copied the parathyroid hormone feedback loop that I demonstrated for you, it's not correct. Okay, calcitonin is essentially opposite of parathyroid hormone, so it gets its own feedback loop. So we start with homeostasis. You need a homeostasis box. Then a stimulus occurs. Again, there's many different stimuli that could create the necessary change. Then you're going to have a change in blood calcium. You may also see that written as blood serum calcium or serum calcium. It's all the same thing. So you have to figure out, for calcitonin to be secreted, does blood calcium have to increase or decrease? Which of the two will signal or will kind of start this feedback mechanism? Okay, so it's one or the other. There's only one right answer for this box. Then we have a sensor gland. Now, there is actually only one gland at work here in this feedback loop. I'll go ahead and tell you the hypothalamus is not part of this feedback loop. This gland can be signaled by the hypothalamus. However, in this specific feedback loop, calcitonin does not need to be stimulated by a hypothalamic hormone. So we just have one gland in this instance. And it's the gland that secretes calcitonin. So we can go ahead and actually put in this box. So we already know that because calcitonin is our hormone in question. So from here, where is calcitonin going to go? What is its target? When it reaches that target, how does it interact? So what does it do at the target? We can't just say, okay, calcitonin is secreted, and it changes blood calcium, blood calcium increases, decreases, whichever you determine. We have to actually talk about what calcitonin interacts with to create that result. So, calcitonin is secreted from the gland, the sensor gland. What's its target? Where does it travel to? How does it interact with that target? And then what is the result? Again, the result, just like in our other feedback loop, should be opposite of the change. So if blood calcium rises after the stimulus, blood calcium should decrease. If blood calcium decreases after the stimulus, blood calcium as a result should increase. These should be opposites. And that brings us back to homeostasis. That balances the scale. So, for your calcitonin/blood calcium feedback loop, you should have at least these parts. Now, you can, break it down differently, or you can put more or less things in boxes. Like I had mentioned, formatting, you get some freedom with formatting, but it does need to be in a loop. It's a feedback loop, and you need at least these many parts. Now, I didn't just make these up. These are described, let me pull it up, in the assignment. So, title, stimulus, change, sensor gland or sensor organ, targets, output, result, homeostasis. So, these two have all those things. So, I'll give you one last look. Again, your ADH water volume negative feedback loop. And then the calcitonin blood calcium feedback loop. And I'll say it one more time. You can choose the stimulus. There's different stimuli that can create the required change. But there is a right answer for this box. And then there's also a correct answer for this box. Is calcitonin secreted when blood calcium rises or when blood calcium falls? Is ADH secreted when water volume increases or when water volume decreases? Okay. Find a stimulus that would create that change. So, I'm going to return your work from week 5. I'm going to give you however long you need to look back through your feedback loops and make any changes. Then you're going to resubmit your work, and we will go from there. Just let me know if you have any specific questions after watching this video.